motor in RPS. So remember this. Now if we have started the design of 3-phase induction motor, we have to separate D and L. So how to separate D and L? So we can separate D and L, or this D square by L ratio, by using this L by tau ratio. Now what is this tau? So tau is pole pitch. Pole pitch means what? Peripheral distance between center of the two adjacent poles. So generally number of poles are given by the manufacturer, by the supplier, or by the consumer. So if a consumer wants 2-pole motor, so it is a known quantity. P is a known quantity to us. Now pole pitch is nothing but pi d upon P. Pi d is what? Pi d is nothing but your 2 pi r. 2 pi r means what? Total perimeter of your stator bore. So total length divided by number of poles, it will give you the pole pitch. And depend on this L by tau ratio, we can use, or we can design the motor. So for minimum cost, your L by tau ratio should be between 1.5 to 1.2. remember this thing. For good efficiency, your L by tau ratio should be 1.5. For good overall design, your L by tau ratio should be 1. So the manufacturers, they are generally considering L by tau ratio as 1, because for good overall design, we are using this ratio as 1. So remember, if you want to separate D and L, so good overall design should be, or the ratio of L by tau should be 1. Now next concept is nothing but your peripheral speed or velocity. Peripheral speed is given by pi d n. Now this n is again in RPS. So n, which is speed in RPS, which is given by small n, or you can write it as a small n suffix s, no problem. So peripheral speed is given by pi d. Again pi d is nothing but your 2 pi r, which is the perimeter of your stator bore, and ns. So the maximum permissible peripheral velocity for normal construction is 30 meter per second. So this is the normal range, and for special motor you can go for 60 to 75 meter per second. But normally for any induction or normal induction motor, we are using 30 meter per second as a maximum permissible velocity or peripheral speed. Now ventilating ducts. Now as you know, if you go on increasing the length of your induction motor, so it is very difficult to cool the motor, because as you go on increasing the length of the induction motor, it is very difficult to cool, because many hot spots are created in between the rotor. So to cool the motor effectively, we are providing some ventilating ducts. Now see this rotor, this is the practical rotor, squirrel cage rotor. Here some here in this portion, some ventilating ducts are provided. These ventilating ducts are called as radial ventilating ducts. So why these ducts are provided? To effectively cool the motor. Okay, so now if you are providing the ventilating ducts to the rotor, your gross core length will change, LG will change, because of that radial ventilating duct. So LG is equal to L minus ND minus WD. Now here L is nothing but your, suppose consider it as a total L, this one is L. So L minus ND, ND stands for number of ducts. Suppose there are 2 ducts, into width of each duct. So 2 into width of each duct. Now here we have only provided 1 duct, so here ND will be 1. Here in this case ND will be 1 into width of duct, suppose it is 2 centimeter. So the L, suppose it is having 100 centimeter length, then the gross core length is L 100 minus 2, which is 90. This is just for example. So here, because of ventilating ducts, your gross core length will change.